All right, here we go. So, hi, welcome in. My name is Corbin. I just recently started this channel to kind of document my projects that I'm going to be working on. So this video is going to be about what I've learned so far from pulling PET filament out of soda bottles. What I've been using primarily are 2-liter soda bottles. Primarily, exclusively. I've been exclusively using 2-liter soda bottles. I don't think you can see them. I got a pile right here. There are 9 bottles right there. I have another 2 over here that are just waiting to be prepped, cleaned, and then pulled. Right down here, I have a couple samples from what I've done. I have some prints that I learned from, and I also have my puller that I made here. I'll get into this in a moment. But let's just start from the beginning of the process. Big thing number 1 is that the cleanliness of your bottles is extremely important. For example, these 2 bottles are not the same. This one with the lid on it has not been rinsed. This one has. This one still has some soda left in it. Not much, just a little bit, dribbles here and there. This one has been rinsed and the water inside has been allowed to dry. So I'm going to have to do another rinse and a wipe down on it just to get any kind of weird residue off. That's one of the things that you have to keep in mind, is that anything that is on the plastic, once it comes through, is going to be in your filament. I know that if you've watched any recycling videos about 3D printing filament or recycling, whether it's shredding things and extruding new stuff or the pultrusion method like this, is that, garbage in, garbage out. There's that whole ideology there, and it is 100% true. These first samples were not absolutely perfect, but I'm learning. I've only done, I think, 5 or 6 bottles at this point, maybe 7. All been done with this machine to various levels of success and printed on one of 2 printers, which we'll get into here in just a little bit. So, as far as prepping the bottles, what I have found works best for me after trying a couple different ways, rinse the bottles out, try to make them clean on the inside, and then go ahead and I'll use my heat gun, which I have very professionally attached to my upright on my shelf right here, with 2 definitely gonna stay there forever zip ties. And I'll just put that on low and kind of hold the bottle above it, focusing mostly on the glued area where the adhesive is. And this is not to melt the glue, this is to soften it so that when you peel the label off, it peels very cleanly. And what I've found is if you soften it, you don't deform the plastic by doing this if you are careful and are patient with it. But if you're able to get this label off very cleanly by doing this, all you have is the glue left, and you don't have to worry about getting any of this label material off, because that is a pain. It really is. The very first one I didn't do the heating method properly. The glue was able to harden again before I peeled it off. And then I peeled it, and I spent 20 minutes trying to scrape off glue with an X-Acto knife. Don't do that. It's not the right way to do it. What I did is I just used some adhesive remover. I originally got this to get some carpet tape off of my garage floor where my workshop is. Haven't done that, but just take a paper towel, spritz a little bit of this on there, wipe it down clean. It gets the glue off very nicely. You just let it evaporate off. This particular one, it'll just evaporate away, and then I'll give the whole bottle a good wipe down with some isopropyl alcohol to get rid of all that stuff, and then just water. And that usually works out pretty well. So heat gun and adhesive remover, fantastic combo, 100% recommend. Definitely go that way. Or find a better way that works for you. Don't just go for it. Preparation is vital to success, and I've learned that the hard way, so hopefully you do not have to. Now, another thing that I did differently right away is all of these clear samples, which were the first 5 or 6, I did differently to this green one. There we go, this green one. And I did that deliberately so that I can have one method versus another method, and I would have a very clear distinction between the 2. And that's just for me to make things easier so I don't have to label things. The difference is the method of creating the strips. Because if you're not familiar with the process, here's a very basic rundown of the pultrusion process. You take the bottle, you get it all clean and stuff, you cut the bottom off, you make a little strip, and then you have to strip the bottle into very long, thin strips, usually about 8 millimeters in width. And then that gets pulled through the nozzle here and wound around this little spool, basically. But in order to create the strips, the machine that I'm using right here is the Recreator 3D version something that I made out of an Ender 3 Pro a couple years ago, and I only recently started to use. Well, a year ago I made it, and I've just recently in the last month or so started actually using it, and it works pretty well once I figured out worked out a couple bugs. I might make another video on this later. If that sounds like an interesting thing, let me know, because I think it'd be really interesting to go through the successes and failures I've had with this and what I've learned along the way. But anyways, bottle sits on the rod right here, and then the strip is fed through these two sharpened ball bearings, these sharpened bearings, which are pulled through the whole thing, and that cuts your strip. There are two ways to do it though. You can either let the machine do it, or you can clamp this down and pull it by hand. With all these clear samples, I pulled it by hand because I wanted to make sure that the rest of the machine worked. I wanted to eliminate a potential point of failure until I made sure that the entire machine works. That was one thing. I also wanted to see if there's a difference in the results, which we'll get into here in a bit. And then obviously the green one, I mounted the thing on the machine, and the first couple of feet I did strip by hand just so it would feed onto the spool, but then after that it was all on the machine. But then my sample prints did not get that far. Between the two methods, honestly I could go either way. When you pull it by hand, the biggest problem I've run into with my current setup is you'll have the big long strip, which is tricky to manage as far as when it's being fed through the machine, because the spool, this big gear attached to where the spool goes, or where the filament ends up, is what drives the entire process. So it's constantly pulling that way. So all the rest of your stuff is just sitting out here, and it's, let's just say it doesn't like to stay anywhere. I tried spooling it onto like this clear spool because it had a nice shaped hole in it that I could use for the strip, and that worked okay, but you don't have a whole lot of it, so it doesn't take up a lot of room. Like you can see there's a whole sample on here, and it's hardly taking up any of the thing. So just take all of this, flatten it, and that's what you have. It's not a lot, so it tends to shift. And when it shifts, it can kind of get under themselves, like under the strips, and then tangle, and then you get problems. That's the biggest issue I've had. Well, two issues actually. The tangly getting just wherever, and then keeping the strips clean. My workshop here is not the cleanest place in the world. There's like bits of sawdust, and there's cat hair, people hair, dust. It's in my basement, so there's particulates around, you know, and I'm sure that's a common occurrence in most places. I don't really have the ability to be in a dedicated space. This is as good as I can do, is this area that I'm in right now. Based on what I've seen with all my testing so far, is that it's not a huge problem. But it depends on the size and type of particulates getting into your stuff. And so based on your situation, it may be a bigger issue for you than it is for me. So that's definitely something to keep in mind. That doesn't really happen when you have the bottle on here being fed by the machine. I will say though, when the machine is doing it, something that I have noticed could be a problem with my cutter, but what tends to happen is the bottle will sit here and it'll be pulling through, and it'll just kind of sit, and it'll be pulling, and it'll just kind of flex this plate, and it'll get to a point where it'll just snap back, and then it'll cut and go through, and it'll just kind of do that. And so you get this really interesting seam pattern. I don't know if it'll show. It's really hard to see what I'm talking about here with the seam pattern, but it's definitely rough is the best description I can think of. However, that didn't give me any issues printing at all. None. No issues with this sample, and there are reasons that I'll get into that may have affected that, but with some of my earlier samples of this, I had tremendous issues. but that may have been because of something I'm about to talk about here, which is the printers. Printer settings for this kind of material are way different from most modern filaments. Like I have a whole bunch of hyperfilaments over here and they print super fast and they have fantastic properties because they are meant to be 3D printed. This stuff is not meant to be 3D printed originally. We're just kind of forcing it to do that because it can. That being said, when it's set up properly, it does pretty good. However, when it's not set up properly, it does not so good. And we'll get into this here right now. For reference, I'll give you what my general print settings were. The flow rate on these two was adjusted because, well, on everything was adjusted because it's creating a hollow tube rather than a solid core filament. So you have to increase the flow to compensate for the lack of material. So generally it's about a 1.3 flow rate rather than like a 0.9 to 1-ish that you normally get, at least from what I've seen. These two were printed on the same machine with two differences. This sample was printed with a flow rate of 1.3 with a nozzle temperature of 250 degrees Celsius. This one was printed with a flow rate of 1.4 at 260 degrees. And there's a reason for that I'll tell you about why I changed my mind. If you look, you can see we had some pretty serious issues with the quality of this. This, by the way, this is when this one's made out of PLA, and it's just a little sample spool that I was printing to hold this material. Pretty serious layer adhesion issues, and you can see on the first layer here, you have these like strips of kind of missing material. Now at first I thought that's because I had a flow problem, which is why for my second attempt I increased the flow to 1.4 to see if that would change anything, and it turned out exactly the same. Had the same first layer issues. This is a different model, but the same issues persisted, so it's not a model problem. The only settings I changed were the flow rate and the nozzle temperature, and it had the same problem. So I can rule out the flow rate issue. As I was observing the print, it was printed on this printer right over here. This is an Ender 3 S1 Plus. Usually it's a pretty decent printer. It's several years old now and not, fast or speedy or flashy or anything, but it works. The problem that I had with it is that it wasn't consistently feeding. And I think it's probably because of the way the extruder is designed. I don't know exactly, so I'm not going to get into it. All I know is that from what I observed, it wasn't consistently able to grab and feed the filament. So I was having parts where, like if we see here, sometimes the layers were going down just fine and it was printing okay. And other times where the flow completely stopped. And so you have super inconsistent flow. So no amount of flow compensation will fix that. So I said, okay, maybe it's a printer problem. I moved over to my Creality K2 Plus. They're both Creality machines, by the way. I moved to my K2 Plus. I wanted to use this one because it would be a whole lot easier to clear any jams or clogs. This one's not as easy to clear jams and clogs, but I basically just bypassed the whole PTFE tube and fed it straight from the top with a very temporary solution. You can't see it because it's ghetto, but basically I'm just feeding it like I would TPU, just from the top without the lid on. And that worked fantastic. It printed this sample right here. Printed this sample benchy out of the green sample, which was the one that was machine pulled. That's how I'm going to differentiate them, machine versus hand pulled. This one here, they printed this benchy. And I think it turned out very well. The layer lines are very smooth. I don't see any under extruded portions like I was having before. Again, same print settings. This one was 1.3 flow at 260C, and I don't see any under extrusions. I don't see over extrusions. It looks fantastic. The bridging looks very good. The arches are fantastic. The only issues I've seen on this one, other than the fact that the smokestack is gone, is there's a bit of stringing. It's really tricky to see with my camera set up here. But in these little spots where there's short travel distances, there's some stringing. And I believe that's because I need to decrease my accelerations, because I forgot to change the move speed and the acceleration. So it was still doing its travel speed at 400 or 500 millimeters a second at 12,000 acceleration, which is quite fast for printing at 30 to 40 millimeters a second. I will say, this was my actual first attempt at the Benchy. Obviously it failed after a few layers. I don't know exactly what happened. It printed the first few, it stopped extruding, and I thought it had the same problem as my other one. I was about to give up, but I just unloaded it, cut off the problematic area, reloaded it, hit try again, and very next attempt, perfect print. I will say the smokestack was attached when it was done. And if we look at the smokestack, it printed really well. It's really hard to see because this is not a macro camera, but no blobbing, no issues, and I couldn't be happier. It does seem to have some layer adhesion issues because I didn't push very hard when this broke. I just wanted to see, hey, is it strong? I was kind of squeezing it, testing a little bit of strength, seeing if it was going to break, and I just barely pushed and it just popped right off. I moved on because I thought, hey, maybe this is because this was machine pulled, maybe it had a more consistent diameter. They're all in the 1.7 to 1.85 range, so it's not super like factory smooth, but from what I've seen measuring with my calipers, that's about what they were. This one was made obviously with the hand-pulled samples. This used 3 different samples or sample lengths. A couple that were used previously for these 2, and then one that was just a different sample that I have on the spool loaded in right now. Now with this one, you can, let me see if I can find it here. You can see where I had new materials. So there's a little blob right down here, and that's where one material changed from one to the next. This middle section, that's a little bit, it's really hard to tell here, but you can kind of see a line right there where there's just a slight difference in color, and then the rest of that was that third material. And again, it mostly printed super well, like absolutely wonderfully. The lines on the hull are fantastic, the overhangs are great, the arches are amazing. Again, a little bit of stringing, but I think that's a travel speed and acceleration problem. And it came out with this really nice, it's not quite clear. It's almost like, it's really hard to describe this color. I think of like black and white comic book pages. It looks kind of like that paper, not white, but not gray. Anyways, one thing I wanted to talk about was layer adhesion, because with that smokestack coming off, I thought that might be an issue. And so I have also a regular PLA. I should have done PETG, but I didn't. I have a regular PLA Benchy here, same model, printed on the same machine. Obviously different settings for the material, but I wanted something to test it against. So this one came off really easily. So I want to try this one here, see if it's just like a fluke. Nope, that just snapped. Like, I hardly moved at all. Like, I can't, it's really hard to tell, but you could see I only used one finger. I kind of went and it popped right off. If I do the same approximate force on PLA, nothing. Obviously PLA has pretty good layer adhesion properties, and I'm actually using quite a bit more force right now in this direction, and I'm not even deflecting it at all. That's going to take a significant amount of force to break, and I don't want to break all my Benchies. I thought that was interesting. I don't know if that's a fluke. I don't know if that's a problem with my settings or my material, but it's something I'm going to look into. However, I will say, one of the biggest things that I found, that I've learned so far, is that your choice of printer matters. Mostly the extruder, I believe. You definitely want something with dual gears that can grab both sides of the filament, because it is hollow. It's not a solid core. So you have less material really to grab onto. And especially when it's a bit warm, when it's in that extruding area, it can give a little bit. And so there's not a whole lot to grab. So if you're grabbing it from one side, it may give rather than grab, if that makes sense. And I think that's probably what was going on with this one. Either that or it just wasn't tensioned enough, so it couldn't grab tight enough. But had no luck on this one. Great luck on this one. I don't really know what else to say other than that's what I found so far doing these samples here. Another thing that I would like to mention is because the yield on these bottles is not really high. Here's a little sample spool. These usually hold between 50 and 100 grams of filament, I think. And it's maybe, we'll call it a third full. If this holds 100 grams, that's about 30-ish grams. It's probably somewhere between 20 and 30 grams. I don't have a scale. That's something I would like to get at some point so I can keep track of this kind of thing. But you don't have a whole lot of material. For example, this print here, both of these used about 15 grams of filament. If you add this one, we'll call it another gram or so, and I have this much left. Not a lot of filament, which means that I would really like to find a way to weld them together. I do have a Sunlu filament welder. I don't think that would work out very well. I've read a lot of advice against that particular one. I've been looking into alternatives because it is something I would like to do a lot more often, especially with testing. I just am intrigued with the whole recycling process, especially when it comes to 3D printing and other things where you can just use the stuff, do what you want to with it, and potentially find use in garbage. They seem fairly tough. I need to figure out if the layer adhesion thing is a problem with me or my process, or if it's just a property of the material. Because that's definitely something that you're going to want to keep in mind if it's a property of the material, but that'll take more research and or testing on my part to figure out. So don't take that as a conclusion. It's just current results based on what I have so far, which is not a lot. We're going to talk now about, just for a minute, about some things that I would like to change moving forward. I mentioned I want to get a welder of some kind. I've been looking at the Tillman design stuff. It looks really neat. I'm going to look into that and potentially pick one of those up at some point in the future. Something else I'd really like to do is get my hands on some different machines to do some other testing. That's kind of hard to justify right now for many reasons, but it may eventually happen. I've been looking at some Prusas, especially the XL. It just intrigues me. I'd love to get my hands on one of those. But right now, I have the K2 Plus, I have the S1 Plus. They both work for the most part, and I'll make do. I would like to get a welder of some kind to just make more usable spool sizes, because these are pretty tough. Like I said, this one benchy, again, 15 grams, I did use 3 different filament samples to do because I was piecing together scraps, essentially. I'd also like I mentioned, I'd like to get a scale to keep track of yields. I would also really like to do is, I would like to get a microscope to maybe take a closer look at these layer adhesion issues, maybe look more closely at layer lines or at failed prints, so you can actually just see how it's extruding rather than just, oh, it failed, bummer. I'd like to learn some more information and put together some more complete analysis of these materials, and then other materials as well that I look into. I also want to, of course, refine my process. That's what I'm doing constantly. I had an issue with this machine at first, mainly a user error issue. This fan is meant to be mounted over the nozzle assembly here. It wasn't able to heat up all the way doing it that way, so I had read that you could just remove it, and it did work. It heated up, but it also transferred a lot of heat to the base plate here, which caused significant warping. So it's printed out of ABS, but it wasn't printed out of ABS properly. I don't think it was, I think this was 2 perimeters, 2 top and bottom layers, and then maybe 20% infill. This one I printed is with the standard ABS strength preset for 0.2 millimeter layer height on the Creality slicer. I think it was like 5 perimeters or it was 6 perimeters and 5 top and bottom layers and like 30 or 35% infill. So significantly denser part, but I also zip tied the fan next to it. You can see if I pick this up here, next to it, so it's blowing on the plate rather than the nozzle. So the nozzle still heats up just fine, but the fan cools the plate, and I haven't had that issue at all. it's been rock solid ever since. And I've done, like I said, half a dozen bottles since then, and haven't had any issues with it at all, actually. So I'm very pleased with that, and I think I'm going to stick with it. As well as, you know, with my bottle preps, I want to make sure that they're definitely clean. I want to keep them clean throughout the pultrusion process. I want to see if drying makes a difference. These ones have been sitting in dryers. I know PETG does have pretty big issues with moisture. I don't know if PET does, and I don't know if bottle PET does. So I would like to look into that. But those are all future plans, and I'll need to come up with some testing methodology to validate any of this stuff that I'm looking into. But I think I've rambled on long enough. That's a lot of the stuff that I've learned pultruding PET filament. If you have questions that you'd like me to get into, like something that I didn't explain very well or could explain more thoroughly, please let me know, and I will try to answer them as best I can. If I get enough, or if I get good, like really good questions that I want to expound upon more than just a little comment, I might make another video. But I just wanted to go over some things that I've learned. It's not everything that I've learned, but it's a lot of the things that I didn't quite think of before I started this whole process. And I think maybe someone else can learn, and obviously I'm continuing to learn throughout this whole process. And that's part of why I'm documenting this. So if you liked it, let me know. If you have any advice, tips, or tricks, I'd love to hear it. If you want to see some more stuff and just watch how my journey goes on, feel free to stick around. I'd love to, see some people that are just as interested in this stuff as I am. So anyways, I think I'm going to cap it off there. Thanks for watching, and we'll get back to you with another video another time. So, see you guys later.